An exponential function is a function where your exponent is a variable. And today we're going to look at graphing exponential functions. Graphing an exponential function is just like graphing a linear function or a quadratic function. We need a table. And what we're going to do is we're going to take this y equals equation and we're going to plug it into our calculator to create a table. Okay, so let me pull up my calculator here. What we're going to do is we're going to go to y equals. And when we get to y equals, we're going to put in 3 raise it to the x power, just like that. And we're going to go to second and then hit our graph key, which will create a table for us. Now when you look at this table, what I want you to notice is that you have some numbers that are decimals, and the decimals are going to keep getting smaller and smaller and smaller, and you have some whole numbers. Now the important thing to know is these decimals are going to keep getting smaller and smaller. Every time we go up a level here, it's like we're dividing it by 3. And we're going to keep dividing and dividing and dividing, but we're never actually going to get to the point where our y value is 0. If we go down, we notice that it's like multiplying by 3. And as a result, our numbers are going to get very big very quickly. So when it comes to making a table, what you want to think about is putting on about 2 or 3 decimal points and as many of the whole numbers you can that you think you can graph on your graph, that you can make fit. Now when it comes to putting these points onto your table, the whole numbers are easy. So I'll put those on first. I go over 0 up 1, over 1 up 3, over 3 up 9. Those are the easy points to put on. These decimals are a little trickier, so you're going to have to do some estimating. 0.333 is a third. So what I'm going to do is I'm going to go -1 and then up about a third. I don't know exactly where it is, I'm just going to guess. I know that 0.1 is going to be a little bit less than this. And I know that 0.4 is going to be even less than that. The important thing to know is I never hit 0. Okay, these decimals keep getting smaller and smaller, but they're never actually going to hit 0. And so what I'm going to do then is connect these points, and I see that they make this nice curve, which we call an exponential curve. Now, there's a couple things to know about this graph. The first thing is you will notice that the graph is never actually going to touch your x-axis in this case. Okay, that x-axis is what we call an asymptote. An asymptote is a line that we have that this graph will approach, but it's never going to cross it. Sometimes it'll be the x-axis, like in this case, and sometimes it'll be another point on our graph, but the curves will always get really, really close to something, but never actually touch it. The other thing you might be asked to do is to find an exact value. Okay? We'd graphed 3 to the x power, but what if I want to find out exactly what 3 to the 1.5 power is? Okay, if I look at my table, I don't have an x value for 1.5. So what I do is I go back to the main screen of my calculator, and I can just put in 3 and just raise it to the 1.5 power. And when I do that, I get this big long decimal, and I'm just going to round it. Usually you'll be told 1 or 2 places. If it doesn't tell you, you get to pick. So I'm going to say that 3 raised to the 1.5 power is about 5.2. Okay. Now I brought this one up because I want to show you what happens when you have a fraction raised to a power. Now the fraction can be entered into your calculator one of 2 ways. Okay, if you go to y equals and you want to put this into your calculator, if you're going to enter it as a fraction, make sure you put that fraction in parentheses and do 1 divided by 2. Close your parentheses and then raise it to the x power. If I were to type it in just like this and I did 1 divided by 2 and raise it to the x power, then the exponent's only being applied to my denominator here. Okay? So I don't want that to happen. That's why I put the whole thing in parentheses, because I want it to apply to the entire fraction. Now if you have a fraction like 1/2 that terminates, you are able to put it in as a decimal. So I could have also put this in as y equals 0.5 to the x power. Both of those would give me the same table. So now, if I go to my table, I'm going to see that I have these numbers. And again, the rule is a couple of decimal places and as many whole numbers as you think you can make fit. So I have this table. And what I'm going to do is I'm going to graph it. So I'm going to go -3 up 8. And then I'm going to go -2 up 4, -1 up 2, 0, 1, and then again I'm estimating that's about a half, that's about a quarter, and when I connect these points together, Okay, I'm going to do my best to connect them as a curve and be very careful that I get close to this line, but I don't ever cross it. Remember, that's my asymptote. Now, some other things you might be asked. Sometimes you'll be asked to identify your y-intercept. Remember, your y-intercept is the place on your graph where your x value is 0, which would be right here. And so you can say your y-intercept equals 1, or you could write it as an ordered pair, 0, 1. And then again, if you have something like this, you can either enter this into your calculator on the main screen as a fraction, like that, or if you wanted to, you could do 0.5 to the negative 2.3. Either of those would give you the same answer, but remember, to do that, you go back to your main screen, okay? And what we'll do is we'll put in 1/2, close those parentheses, raise it to the negative 2.3, and then hit enter, and what I see is it's about 4.9. Now, one thing to keep in mind, see how this was a fraction? My fraction starts tall and it gets less and less and less and less. As we think about it, what we're doing is we're taking half every time we go down here. Now, if we go back to our original graph, we started with a whole number, which meant it started low and got very, very big. It increased because, in this case, we were doing times 3. Okay? So depending on whether you do times 3 or times 1/2, it's going to determine whether you have an increasing or decreasing curve. Now, the other thing I want to show you is both of these curves had an asymptote of our x-axis. They got really, really close to where x was 0, but x never actually got to be 0. That's not always the case. Sometimes your asymptote will be a different number. And here's an example. This right here is going to change what our asymptote is. So when we put this into our calculator, we're going to start off exactly like we have been. We'll do 2 and raise it to the x power. But then we also have to add 3 to it. So essentially, it's taking this curve that would have been 2 to the x power, and now we're going to raise it up 3 places. So when I graph this, and I see my table, we can see all my decimals here are above 3. If I keep going up, I'm never going to get to the point where I'm lower than 3. So I'll create my table, and then I'm going to put these dots on this graph. So negative 3. I need my pencil, and then up 3.125, 3.25, 3.5, 4, 5, 7, and 11. So now when we look at this curve, again, we can see it does have an asymptote, but our asymptote is no longer the x-axis. Now my asymptote's way up here, okay, where y equals 3. Okay, so this value will control where your asymptote is. And that's all you need to know about graphing exponential functions.